A power outage is the loss of the electrical power network supply to an end user. There are many causes of power failures in an electricity network. Examples of these causes include faults at power stations, damage to electric transmission lines, substations or other parts of the distribution system, a short circuit, cascading failure, fuse or circuit breaker operation. Power failures are particularly critical at sites where the environment and public safety are at risk. Institutions such as hospitals, sewage treatment plants, and mines will usually have backup power sources such as standby generators, which will automatically start up when electrical power is lost. Other critical systems, such as telecommunication, are also required to have emergency power. The battery room of a telephone exchange usually has arrays of lead-acid batteries for backup and also a socket for connecting a generator during extended periods of outage. Power outages are categorized into three different phenomena relating to the duration and effect of the outage. Rolling blackouts occur when demand for electricity exceeds supply and allow some customers to receive power at the required voltage at the expense of other customers who get no power at all. They are a common occurrence in developing countries and may be scheduled in advance or occur without warning. They have also occurred in developed countries. For example, in the California electricity crisis of 2000-2001, when government deregulation destabilized the wholesale electricity market. Blackouts are also used as a public safety measure, such as to prevent a gas leak from catching fire, or to prevent wildfires around poorly maintained transmission lines. In power supply networks, the power generation and the electrical load must be very close to equal every second to avoid overloading of network components, which can severely damage them. Protective relays and fuses are used to automatically detect overloads and to disconnect circuits at risk of damage. Under certain conditions, a network component shutting down can cause current fluctuations in neighboring segments of the network, leading to a cascading failure of a larger section of the network. This may range from a building, to a block, to an entire city, to an entire electrical grid. Modern power systems are designed to be resistant to this sort of cascading failure, but it may be unavoidable. Moreover, since there is no short-term economic benefit to preventing rare large-scale failures, researchers have expressed concern that there is a tendency to erode the resilience of the network over time, which is only corrected after a major failure occurs. In a 2003 publication, Carreras and co-authors claimed that reducing the likelihood of small outages only increases the likelihood of larger ones. In that case, the short-term economic benefit of keeping the individual customer happy increases the likelihood of large-scale blackouts. The Senate Committee on Energy and Natural Resources held a hearing in October 2018 to examine Black Start, the process of restoring electricity after a system-wide power loss. The hearing's purpose was for Congress to learn about what the backup plans are in the electric utility industry in the case that the electric grid is damaged. Threats to the electrical grid include cyber attacks, solar storms, and severe weather, among others. For example, the Northeast blackout of 2003 was caused when overgrown trees touched high-voltage power lines. Around 55 million people in the US and Canada lost power, and restoring it cost around $6 billion. Computer systems and other electronic devices containing logic circuitry are susceptible to data loss or hardware damage that can be caused by the sudden loss of power. These can include data networking equipment, video projectors, alarm systems as well as computers. To protect computer systems against this, the use of an uninterruptible power supply or UPS can provide a constant flow of electricity if a primary power supply becomes unavailable for a short period of time. To protect against surges, which can damage hardware when power is restored, a special device called a surge protector that absorbs the excess voltage can be used. Restoring power after a wide area outage can be difficult, as power stations need to be brought back online. Normally, this is done with the help of power from the rest of the grid. In the total absence of grid power, A so-called black start needs to be performed to bootstrap the power grid into operation. The means of doing so will depend greatly on local circumstances and operational policies. But typically transmission utilities will establish localized power islands, which are then progressively coupled together to maintain supply frequencies within tolerable limits. During this process, demand must be reconnected at the same pace that generation is restored, requiring close coordination between power stations. T.